Okay, so in this video we're going to talk about logarithmic functions and how they relate to exponential functions. So firstly, if we look at a logarithmic function, remember a logarithmic function is just the inverse of an exponential function. You basically take the you take an exponential function, switch the x and y values, and solve for y, and you'll get a logarithmic function. If you have an exponential function such as 3 squared equals 9, you can rewrite that as a logarithmic function. You take the base of the exponent, which is going to be the base of the log, and then the number that it's set equal to is what you're taking the log of, and then whatever the exponent is what the log is set equal to. So if you practice rearranging exponential functions and logarithmic functions, you'll see that the two functions are really related, and you'll be able to work with them a whole lot easier. So for example, if you're given an exponential function like log base 2 of 8, and you're asked to simplify that, obviously when you see something in logarithmic form, it's a little bit harder to work with. So if you're ever asked to find the log base 2 of 8, the simplest thing to do is first rewrite this as an equation, or set it up as an equation, set it equal to x. Now that it's an equation, we can use what we know about exponentials and logs and rewrite this. The base of the log is the base of the exponent. The number that it's set equal to is your exponent, and then what you're taking the log of is what it's equal to. So now we can look at this. How do we figure out what do we need to raise 2 to get 8? Now most of you are probably thinking, oh, well 2 cubed is 8, so x obviously has to be 3. And you can do that in this particular problem, but in some problems it's not going to be quite as obvious. So I want to show you the thinking behind simplifying something like this when it's not quite so straightforward. The easiest way to do this is to look at each term as an exponent, and you want to try to get each term as an exponent with the same base. So if we rewrite this, 2 to the x is equal to, what can we write 8 as a power of 2? And yes, if we think about it, 8 is 2 cubed, right? So if you can rewrite 8 as a power of 2, then we've got 2 to the x equals 2 cubed. And since the bases are the same, their exponents have to be the same. So that tells us that x has to be 3. Okay, so now let's look at log base 3 of 1/3. Again, let's set it equal to x, set it up as an equation. And now let's rewrite this as an exponential equation. So the base of the log is the base of your exponent. Your exponent is what it's set equal to. And then we're going to set that equal to 1/3. Now, again, let's see, can we write this equation as an equation of 2 exponents with the same base? Remember, 1/3 is the same thing as 3 to the negative 1, right? So if we write 1/3 as 3 to the negative 1, then we've got both sides of the equal sign, as exponents with the same base. And if 3 is equal to 3, then x has to be equal to negative 1. So now we're going to look at changing exponential statements to logarithmic statements and logarithmic statements back to exponential statements. So we're going to get a little bit more practice with this. So for example, again, if we have 1.2 cubed is equal to m, let's rewrite that as a logarithmic statement. And we're going to say the base, we're going to take the log, the base of the log is the base of the exponent, and then the number we take the log of is what it's set equal to, and then we're going to set that equal to the base of the exponent, or set that equal to the exponent. Okay, next problem. E to the b equals 9. We're going to rewrite that as log base e of 9 equals b. And remember, I don't know if you remember this from last year, but anytime you have log base e is the same thing as a natural log, which is ln. So this is going to be ln of 9 equals b. Okay, and then lastly, if we have a to the 4th equals 24, we're going to say log base a of 24 equals 4. And then lastly, let's look at a couple logarithmic expressions to evaluate. These are a little bit more complicated. So we're going to have to use the little trick that we talked about earlier. If we have log base 3 of 81, first let's set that equal to x. And setting that equal to x, let's convert this to exponential. So we're going to say 3 to the x equals 81. Okay, now looking at this, I don't know about you, but I'm not really sure what I need to raise 3 to get 81. So what I'm going to do is try to figure out, can I write 81 as a power of 3? Well, let's see. Let's do a little factor tree of 81. 81 is 9 times 9, and 9 is 3 times 3. So, oh, look at that. We've got 4 3s. So do you see that that's 3 to the 4th? So 3 to the x is going to be equal to 3 to the 4th. So x equals 4. And a lot of times these problems, you'll find that they always do kind of simplify to be clean numbers. So a lot of times if you do a factor tree, it becomes pretty obvious pretty quickly what you can raise the power to. And then lastly, if we have log base 2 of 1/8, set that equal to x. So we're going to say 2 to the x equals 1/8. Okay, again, this is not quite so straightforward what we need to set x equal to. So I would say anytime you have a fraction, I would go ahead and rewrite that fraction as a negative exponent. So this 2 to the x is going to be equal to the same thing as 8 to the negative 1, right? Because negative 1, raising a power to negative 1 is putting it in the denominator. And now, can we raise 8 to a power of 2? If we do a factor tree of 8, we see that 8 is 2 times 2 times 2, 2 cubed. So 2 to the x is equal to 2 cubed to the negative 1. So 2 to the x is equal to 2 to the negative 3, right? Which means that x equals negative 3. So those problems are kind of fun once you get going on them and see that they're really not so difficult. So I hope these problems help you work with the prep quiz, and we will talk about this some more next class.